Hello YouTubers, I'm checking to see if my Facebook is running live here. Hold tight. Alright, looks like we got everything running here. Welcome to Sunday Fun Days, fellas. We're going to look at MooZilla. We got Molly over here. Hi, Molly. Alright, we'll get this thing started here in a moment.
Yeah. Breaker, no South Jersey checking in. Danny in the shop where the real ones begin. 454s, 2290s, 28 setting knocks. All eight, she's in hard. Billing mud duck slide. Danny the man with that Dave Bay flair. Old school vibe, 90 smoke in the air. Forget that weak 6 pill, high Q noise. This that Jersey Bill heat for the real convoy. Yeah, who I set up, but don't be a clown. Codex 3300 HP max.
What's going on, everybody? So, as you guys all seen in the heading, if you were to stop and read that, no, you may not have. This is a 2027 MooZilla. So, yeah, I'm starting to date these things forward a little bit. We're already doing it with car manufacturing stuff, so there you have it. Let's take and get this thing going. What's going on, Tom? How are you? Welcome to a Sunday Fun Day. So this is absolutely, this build came out just absolutely beautiful. Very happy with it. Take it lower just a bit. All right, so very happy with it, and this is a MooZilla. So if you guys are looking at my listings, I have a South Jersey line, and that's a pretty standard line. And then you got the Psycho Zip line, and those are all 2879s, 1446s, 454s, or 1446s in that line as well, in the Zippy line. But the MooZilla line and the Mowatts line is only reserved for the 2879Cs with no driver. So you will never see me put a driver in a box like a MooZilla or a Mowatts box. They won't have internal drivers. Why is that? Because you have so much more control when you have an external driver versus an internal driver. So these boxes are designed where you can drive these and you can get up in them a little bit, and we just got to break down the math, and you just have to understand where your ceiling is as far as driving each transistor. So when you take in, you can understand that, then you can just pull out a calculator and do some real simple math, but you have to do it when you're reading in RMS or average mode. You can't do this math when you're looking at peak. It just won't add up, and you'll be breaking stuff faster than you could on sideband if you're running a rig on average mode and you're thinking you're driving your stuff properly. You're overdriving it most commonly. So there you go. There's a little spew about that stuff. So this guy wanted a little red and white, and this is the twist I put on it, and I think it turned out really nice. Here's the inside of it. It's all right and tight. Yeah, I still leave that laneway here. I'm just really used to using that area, and I want to just keep in practice. So it just kind of opens up the front end of the amp. It looks nice. Still have my heavy duty B plus on here, and the rest of the dealio. So if you look in far back corner here, you see you got dielectric grease all over that fitting right there. That's your ground. So if you lose ground to an amplifier, you're going to take and put all of that weight of a working ground. That's what I'm showing you here. This is a working ground. That's where you hook your ground cable up to. If you lose contact point there, then the only other ground that you would have on this unit, or any amplifier would go, would leave you down to your coaxial ground. This isn't really designed for a working ground. A huge amperage could draw up to 150 plus amps out of this unit if you were driving it and doing what you can and can't do. All right, so when you take away this ground, this is the only ground that's hooked up. So if anyone's ever hooked up an amplifier in their lives that has two cables and you manually have to hook them up, if you were to hook up the positive first and not hook up that ground, and the switch was on the front of here, this would still be running. Why is that? Because this is still making a chassis ground and it's going through the system. So if that happens and you forget to hook up that ground cable, your amplifier will work. It will be weeping as far as power goes. It will be very low and weird things will happen and you'll hear noises and fans turn on and off and buzzing and carrying on. So just when you take and hook your guys' equipment up, positive line should always be on a quick disconnect no matter what. The ground, I highly suggest just to simply bolt it to the chassis, to the battery, and then off to the frame if you're in a vehicle. In a base station, you go right to the positive stud, negative stud right out of these things, and you plug right into your amplifiers. But again, this is a good mechanical ground. You don't have to, all you need is a screwdriver and an Allen wrench, and this is called an LC40. These are probably about one of the best connectors you could get for the jobs that we're asking our equipment to do to a certain level. Yeah, they rate these at 300-400 amps, continuous hits. We take and do sprag hits, real quick hits, and we might pull on a big box. You could pull 800-900 amps. Sure, it's going to take it, but you're only for that moment. So just make sure when you guys have all your connection points hooked up, make them safe and make them right. So if you cheat on your ground and you cheat on your connector point here, and let's say you say, oh, I like Anderson clips, well, they just rest on each other. You draw enough current, they'll start vibrating. And then what's happening if that's happening is you're not making a strong connection on your B plus and or your B minus, same difference, because they both go into one outlet plug. So again, a twist lock system, so you can see it's a cylinder. Put your finger all the way down in there, it's pretty good size. But these are like $20, $22 for a half a set. This would be one set right here. We have a positive and a negative, or a male and a female if you look at it that way. But the way how this is designed, it has a flat spot, and look way down in there, there's a pin, a silver pin back there. So the flat side runs against it and hits that pin, and then it allows it to go in and just lock. And it's not coming apart. So contact point, if you cheat yourself, you're cheating yourself, period. The amplifier can only pull what you're going to give it. So if you're giving it really good voltage and you have a poor connection, the voltage you'll get there, but when that amperage load hits, it will take in and let you know that you're going to start smelling stuff if you got a weak connection. So anyhow, let's link this thing up. We're going to take in, we are on the antenna. I'm not going to change it right now. So we're going to look at a 25 watt slug. Then we're going to look at a 250 watt slug for the output power. And then we'll look at the digital. Will be on 2500, I believe. I'm not going to sit there and bounce around all over today. So we're going to run a 2500. Let me take and toss the lid on this real quick. 2 108 CFM flow fans in here, and they are all getting across this thing. So let's take and light this thing up. Now we're going to start this party out with a little bit of drive, not a lot. And we are down on this power supply right here. So we're going to be running right around 14.7 or 8 on the voltage. And we're going to take a look at the Texas Star, approximately, I don't know, 50, 60 watts. Not going to be too concerned about dead key right now, just because I'm going to progress forward. So let me just take and make life easy and throw a tone on this. My voice is right around 300 hertz, so this is what we're going to simulate here today. So input reflection slug is a 25 watt slug. Each line is a half of a watt. And then we're going to look at a 250 watt slug for the drive level. So here's our drive level right now. We actually have Texas Star pretty much down. And we're going to look at top scale. Each line is 5 watts. So right now we're only putting right about 45 watts RMS into this unit. And here's your input reflex. So pay attention to this, because as I increase my drive, the input reflex will continue to go down. So right now we're hanging out right around 2.5. And then here, we'll just go right here. We'll say here is your peaker tweaker moment. All right, 1925 here. Let me make sure all the peaker tweakers can see it really good. I want to clean the lens. So this is 45 watts of drive on RMS. So that's my peak right there. I'm hanging out right around 1950. And this is a 2500 watt slug. Each line is 50 watts top scale. And that is you're showing my RMS right there, hanging out right around 650. All right, 650 says there. Let's see what it says over here. Yeah, right there, 650, 700. All right, cool enough. So we're in the ballpark. That's low drive. So if you're a striker kind of guy, that was the numbers you would probably see. And also, here is the amperage and the voltage for both Texas Star and the 8. I'm driving at 45 watts of drive. So we're drawing right around 92, 94, 96 amps, 97 amps. So if you're one of those dual final striker guys and you just gotta have that disco radio, and that's cool. And if that's all you're gonna drive, and this, remember, this is a 2879C. Now if these were standard 2879s, you would probably see a little bit better performance out of this, but the peak on this is still gonna outperform the standard 2879s at this lower drive level at the lower voltage. So just keep that in mind if you guys are trying to decide if you wanted to take and get a 2879C box and get it all done up, or if you're taking and just thinking about getting a standard South Jersey unit. Either way, you can use your strikers with this one piece and it'll work really good for you. You can go out and have a good time. This is my reflection of my antenna right now. So that's 25 watt slug. So I'm showing about 5 watts reflection on my antenna. So let's cruise this up, turn up my power level a little bit. Let me just take a look. I still ain't getting a carrier, but that's all right. We're going to take it and increase my power level. So we took the Texas Star and we carried it wide open. What's going on, Adam? And now we're at 100 watts RMS of drive. And I know, Mark, it says go down to a car dealer. They'll try to sell you a 2027 in a moment. All right, so input reflection. What happened there, guys? It went down. And why did it go down? Because I'm actually starting to saturate the transistors. Because before, I'm going to stop for a second. Let's see if this thing is working. All right, so if we're at 45 watts, a transistor, and you divide that by 8, that's only 5.625 watts per transistor. So we weren't driving these things at all. So actually now we're saturating them at 100. So we're looking at 100 watts of drive, and we're going to divide that 8 times. And now we're at 12.5 watts per transistor. So now she's starting to get a little bit more into the zone of saturation. The transistors are actually starting to say, hey, I'm working a lot better now. I'm eating better food. I have a little bit more drive. I'm not starving. And that's what you're doing when you take and put too low of drive in an amplifier. You are actually starving it. And if you had the equipment to see what I'm showing you, you would see the same thing in your mobile. And I am on the antenna, so I'm not on the dummy load. What happens at 100 watts of drive on 2500 watt scale? Here on the analog, and let's take a look at the digital. And we're right close to it, 1050, somewhere in there. Now, the peaker tweaker, guys, here you go. Here's your little peaking and tweaking. Now, you see that number's really getting filled up pretty quick, and I'm only at 100 watts of drive. So, I'm at 2100 on peak level with 100 watts of drive going into it. And that's approximately 275 watts or 250 watts peak drive watts if you want to try to break that down. We could take a look maybe and see what it tells me on my peaker tweaker. And there you go, 250, 275. So as we take and increase stuff, let's take and see what the antenna was doing here. I stopped midway here, so let's take a look. And the antenna actually came down. You see I was at 5 before. I didn't change anything else. I just increased my drive level a bit. So that seemed to come down. So now, as you see, we're bringing the input drive level up and start saturating these transistors. They start getting really happy. So if I take and I go to the high side of the Texas Star now, and I'm going to give full drive whatever my radio's putting out with this thing. And I just wanted to see what a carrier was real quick. And all right, now let's just take and take a peek. And now remember, we're still hanging out right over here. Now this is the high drive. Here's the low drive again. All right, that's the high of the low. 133 amps at 14.7. Now here's the high side of the Texas Star drawing amperage out of this 8 and the Texas Star as well. So now we're hanging out right around 153 on the amperage with both these units on here. So that's pretty cool. Let's see what drive we were at. Because we were hanging out right at 100 watts before, and now we're hanging out right there at 135. Each line is 5 watts on that top scale. Now input reflection, what happened? Did you dance up or down? You looked like you went down a little bit more. So as you can see, as we keep increasing our drive, everything starts coming into sync really nicely. So you can loaf a box if you like, and there's nothing wrong with it, but sometimes there's a little bit of consequence that comes with it, and it's not a lot. So right here we're hanging out right about 1150, it's showing me here, and let's see, my actual working drive here is 135, so we're at 1150. Now that's all going to increase when I take and increase my voltage here. Now let's see what the digital says. All right, we're showing 1150, 1200 there, and then with the peaker tweaker, and it went up just a little bit. Like I said earlier, I can take and cut this back right here, watch. I went to the low side. So I'm not really gaining any more in peak. Why? I don't have any more voltage. So that means I can put more drive in this and simply just keep increasing my RMS and filling it, but this number is never going to increase until you do what? You increase the voltage on the back end from your power supply or voltage regulator in your vehicle. So let's do that. Let's take and plug in to the next set of voltages. All right. Before I do that, one more click. I think I did not show my reflection to full output power at the level of voltage I'm at. Here's my reflection now. So there, I'm hanging out right around 2.5. Everything's really kind of kosher. And there's your number. Watch that. Watch what happens there. Now I'm only going to increase about 3/4 of a volt just simply by changing power supplies. All right, done. Did it, right? Go right back to this one for you. Went up quite a bit, about 300 watts or so. What happened here? All right, went up a couple hundred there. What happened here? Still hanging out right around the same. What happened to my input reflection? Wow, she's really hanging out right under 1.5 watts and is very happy. And this is my input drive level. That went up. Why did that go up? I didn't change anything. It's because I gave it more voltage on the back end to let the front end or the input of the transistor allow more to get through, because the back door is opened up and more can get out. So I actually increased a whopping 5 watts, but that 5 watts really helps me. Where does it help me at? All over the place. Helps me with the peak, helps me with the RMS. Everything gets increased, even the amperage. We're drawing 142, and that's with, we were drawing that at that voltage. All right. 141, 142, and here's your voltage. Just streamlining it. So any way you want to cut it, we can sit there and just do this all day and talk about it. Antenna. What happened to that? Still hanging out the same spot. Move my in room, because I'm directly below my antenna down the road. So I see Molly. What are you doing, honey? You gonna sit. Hi. You gonna wave? Yeah. What you been doing? You been hanging out? Yes. You waving? Okay, here. You want a peanut? I'll give you a peanut. Here, go. There's a peanut. So, you gonna sit pretty? Sit all the way up. You gonna sit pretty? Yes, you did. You're a good girl, aren't you? Yeah, yeah. All right. So what's hanging? What are you doing? Just hanging out? Yeah. You stretching? You stretching? Huh? Yeah. Do you like your box? Your name's on it. It says MooZilla. That's right. Isn't that your name? Yes? Yeah. MooZilla, sit. MooZilla, sit. You sit. Hey. You gonna sit? So what do you know? You gonna sit pretty all the way up? Oh, you're such a good girl. Here you go. Hey, get some of them. Yeah, Molly's a good girl. She got a spot on her back, man, and they can't do anything about it. We just try to keep it clean about it. What do you think, Molly? You like them peanuts, don't you? Yeah? So what do you think of the box? You love it? It ran good. I know, we talked skip on it today. We sure did. Yeah, we're talking down to Florida. Yeah, we're on the bench. We're on the bench, remember? Yeah. Tom Jones. That's who we were talking to, Tom Jones in Florida. Yep, and he was talking on a Wolf 2100B. Man, he sounded good too. And then I told him to tell Wolf that he did a good job. Yeah. You sit now. You gonna sit? Sit. Hey. Boy, oh boy, you went from loud to quiet. Now I hear his crunchy crunch. Yo, Tom Jones, man, we had a good time. Talked shoot, at least 8-9 minutes on the bench with what we just ran right here on the antenna. So anyhow, guys, thanks for watching. I'm gonna take and slide out of here. Molly wants some more. Hey, sit. You gonna sit? You gonna sit? You gonna wave? You gonna wave bye-bye? Yeah? Waving bye-bye. Wave bye-bye, bye-bye. Good girl. All right, here you go. There's your peanuts. All right. There's Molly's angle. Find them? You get them all, Molly. I left camera on the forward. Oh, there's one. You got the last one, didn't you? MooZilla, come here. Come here. Sit. This is your song, too. You're a movie star. I told you you're a movie star, aren't you? Yes? Yes? You're a good girl. You're a good girl, Molly. Tell him. Tell him about it. Yeah, you tell him. You're a good girl. There ain't no more peanuts left. I know the whole jar's up there. Alright guys, well I really appreciate you stopping by, hanging out with Molly and me, showing you guys this beautiful box. It turned out so nice. Nice looking box, turned out very, very, very well. So there you have it, 12879C MooZilla. Did it up. Alright guys, I'm sliding out here. Take care. God bless. Thank you very much for watching.